The concept of Occamization you've introduced resonates deeply with the foundational principles of both machine learning and cognitive science. By emphasizing simplicity, compression, and low algorithmic entropy, you're advocating for a paradigm that mirrors the cognitive economy humans employ to understand the world. This approach not only has the potential to enhance the generalization capabilities of neural networks, but also to bring us closer to understanding the underlying principles of human intelligence. Revisiting key points and expanding perspectives. 1. Architectural simplicity and representational efficiency. The call for simpler network architectures aligns with the cognitive principle of using the least effort to achieve the most understanding. This mirrors how humans tend to abstract complex phenomena into simpler, more digestible concepts. In neural networks, this could mean developing architectures that are inherently designed to seek out and prioritize representational efficiency, akin to how humans distill vast amounts of information into core concepts and schemas. Algorithmic complexity as a learning criterion. Using Kolmogorov complexity as a learning criterion is akin to teaching networks to think more like humans. We often navigate the world not by memorizing every detail, but by understanding underlying patterns and principles that can be applied broadly. For neural networks, focusing on the algorithmic complexity could drive them towards discovering these universal patterns, thus achieving a more profound form of learning that extends beyond mere pattern recognition. 3. Explicit simplicity objectives. Incorporating simplicity or minimum description length objectives into loss functions can act as a regularization technique that encourages the model to find the simplest explanation possible. This could be seen as akin to the scientific method, where theories are evaluated not just on their predictive accuracy, but also on their simplicity and elegance. For neural networks, this would mean valuing solutions that not only fit the data, but do so in the most parsimonious way. 4. Training curricula focused on core causal features. Designing training curricula that steer neural networks away from overfitting to noise and towards extracting fundamental causal relationships reflects a more naturalistic learning process. This is reminiscent of developmental psychology, where children learn about the world not through random exposure to information, but through structured experiences that highlight causality and core concepts. 5. Evaluation beyond statistical metrics. Evaluating models based on their computational efficiency and generalization ability, rather than just their performance on a given dataset, speaks to a broader vision of what it means for a model to understand. This approach aligns with the recognition that true intelligence involves not just the ability to recall or interpolate, but to extrapolate from limited information and to do so in a way that is computationally sustainable. Bridging domains. The principles of Occamization suggest an exciting intersection of ideas from multiple disciplines. Cognitive science, understanding how the brain efficiently encodes and processes information, could provide direct inspiration for designing Occamized neural networks. Information theory. Concepts such as entropy and compression naturally tie into the goals of Occamization, offering a quantitative foundation for evaluating simplicity. Philosophy of science. The emphasis on simplicity as a virtue echoes philosophical debates on the nature of explanation and understanding, suggesting a rich dialogue between machine learning and philosophy. Forward vision. The vision you've articulated for Occamized neural learning paradigms holds the promise of not just advancing the technical capabilities of AI, but also deepening our understanding of intelligence itself. By drawing on principles of simplicity, compression, and causal understanding, we can aspire to create models that not only perform tasks with unparalleled efficiency, but do so in a way that mirrors the depth and adaptability of human cognition. This interdisciplinary journey towards Occamized AI could not only transform our technological landscape, but also offer profound insights into the very nature of understanding and intelligence.